Welcome everybody to our interdisciplinary blockchain research seminar series. I'm Alex Preda. I organize this research seminar in collaboration with the Department of Informatics and the Law School at King's College London. Our guest today is Tim Roughgarden from Columbia University. I believe that Columbia University, when it was founded, was also called King's College, but then name changed, obviously. And Tim is a professor of computer science at Columbia University. Prior to joining Columbia, he has spent 15 years on the computer science faculty at Stanford. Before that, he did a PhD at Cornell University and a postdoc at UC Berkeley. And his work is situated on the boundary at computer science and economics, and focuses on the design, analysis, applications, and limitations of algorithms. And today's talk is titled "The Long Arm of Theoretical Computer Science, a case study in blockchains, Web 3. Tim, thank you very much for accepting our invitation and being with us today.
Thanks so much, Alex. Thanks for the kind introduction and for the invitation to speak. Very happy to be able to participate as part of this seminar series. I'd say, for this talk, I have probably just kind of two goals, nothing too complicated. Number one, I just want to talk some about kind of the blockchains and the application ecosystems built on top of them. And to convince you, if you're not already convinced, to convince you that there's some super interesting computer science going on behind the scenes there. And, I'm obviously biased as a theoretician, but, my belief is that whenever you see super interesting computer science, theory is inevitably playing some kind of extremely important role, either implicitly or explicitly. And indeed, if you know how to look for them, you can see theory's fingerprints everywhere, all over this application domain. So my second goal for the talk is just to give you a glimpse of a few examples of that. It's not an exhaustive list, but I hope it will sort of illustrate how kind of, 20th century theoretical computer science concepts are sort of have been reborn in this completely new context and are really extremely important for the understanding and advancement of this technology. I should say also, feel free to sort of interrupt with questions at any time. Well, obviously I'll have Q&A at the end, but feel free to also ask as the talk proceeds. So I've been a computer scientist for maybe like 25 years now, and never in my career have I seen a technology that's anywhere close to as misunderstood as sort of blockchains and the applications that are being built on top of them. As you can imagine, once people hear I'm sort of spending a lot of time on this topic, friends, family members, colleagues, want to talk to me. They all have questions. And through, all of these conversations, mostly with extremely smart people, I've come to the conclusion that most people do not actually have even enough of a high-level mental model to think coherently about this technology. May well be a lot of exceptions in this audience, but just in my casual day-to-day conversations, there's a lack of a mental model among sort of the sort of general public. So I wanted to start the talk by offering you the mental model I'm using to sort of look at and sort of reason about blockchain technologies. And I should say, what I write down on this slide and the next slide, it may not really resemble most of the other descriptions of blockchains that you've ever seen. And that's just because I'm not approaching the technology through the lens of investment. I'm not approaching it through some like political lens. I'm really just approaching it through the lens of computer science and specifically theoretical computer science. And so, I wanted to just sort of tell you, what I see when I look at this technology through that lens. I like to organize my thinking about it in terms of three different questions, like what's the what, what's the how, and what's the why of blockchains and their applications. So what do I mean by that? So by the what I mean, I almost want to think informally of the technology as like a computational model. And so the what question is sort of what fundamentally is the functionality offered by this technology that hopefully you did not have before this technology was invented. So for example, you could ask the what question about the internet, and different people might give different examples, but let me suggest that the internet, what it does is it transfers digital data between any 2 points in the globe near instantaneously. And so what you can see from that example is that the what question, if you think about a technology stack with kind of very low level stuff at the bottom and the user facing stuff on the top, the what question is really kind of in the middle of the stack. The answer there lies at the interface between applications that people are building on the technology and the functionality that the sort of the plumbing exports for those applications to build on. So we can ask about the what of blockchains, and I'll give you my answer for that on the next slide. You can also talk about the how, meaning, okay, it's all fine and good to sort of write down some functionality you might want, but then there's the question of, can you actually realize that functionality with existing technology, and if so, how? Right, like the internet, right? Data from any 2 points on the globe almost instantaneously. How on earth is that done? That seems kind of amazing. And the answer is, it's sort of a lot of really hard computer science and engineering. And so 1970, that's when the ARPANET started. So that's when there was first kind of an answer to the how. And of course, engineers and computer scientists have been iterating on the how over the decades. Okay? And so with more advancements, the answer to the how keeps getting better, and the internet infrastructure keeps getting more powerful. Okay? So you would learn about the how in like a serious engineering course, on computer networking in the case of the internet. Okay? And same thing with blockchains. The how is really hard, interesting computer science. Finally, you can ask about the why, meaning, all right, it's all fine to write down this sort of, functionality, but like, why would anyone, what would you actually use it for? Like, why would anyone actually want the technology that did that? And, if you ask this question for the internet in 2022, not a very hard question to answer, right? You pluck anybody off of the street, they're going to be able to give you a zillion compelling answers to the why question for the internet. Why is it interesting that to have data go between any 2 points instantaneously? Well, what do you have? You've got search engines, you've got Wikipedia, you've got online dating, you've got all kinds of stuff. I do feel sort of compelled to mention, right? So the internet's now 52 years old, 1970 to 2022. So if you look at the midpoint, right? So it should be 1996. I was a third-year university student, so I was using the internet such as it was. And the answer to the why question was not so evident at that time. And in particular, all of the killer applications I just mentioned, none of those existed in 1996. Right? So you could send mail, you could transfer files, static web pages had just been invented. So it's not that there weren't any answers to the why question at all in 1996, but the answers to the why question have gotten much, much more compelling as time has gone on. And that's just a useful kind of parallel to keep in mind. So what is the what's of blockchains? What fundamentally do they allow you to do? So a couple caveats about this slide. So first of all, here when I say blockchain, I'm thinking about a blockchain that supports a general purpose smart contract layer. So Ethereum would be the biggest and most well-known examples, but there's lots of other examples now too, Solana, Avalanche, et cetera, and more. So that's what I mean on this slide. Second caveat is that I'm not asserting that what I'm going to put on this slide is like literally true, or even necessarily kind of well-defined in a mathematical sense, but I am offering it as what I think of as a good mental model of how to think about what this technology might enable us to do. So I encourage you to think of a sort of general blockchain as a general purpose computer, okay? Not a physical computer, okay? A virtual computer that basically lives up there in the sky, okay? Think of it as like a virtual machine that's sitting on top of the internet. Now this by itself, right, is not so interesting. We have lots of computers, and moreover, viewed as a computer, a blockchain is about as powerful as the vacuum tube computers that we had in the early 1950s. Okay, so there better be more to the story for this technology to be interesting. Okay, and there is. So first of all, it's a computer that really has sort of no owner and no operator. So you can think of it as sort of just running in the sky as a public good. Okay, I'll say exactly what that means in the next section of the talk. All right, so it just kind of runs, in plain view, in effect, by itself in the sky. It's open access in the sense that anybody can use it, And here by use it, I mean you can install new software. Okay, that would be like deploying a new smart contract, or you can use existing software, meaning you can interact with the smart contracts that have already been deployed. Okay, so a computer that has no owner that anybody can use. Finally, despite the fact that this computer has no owner, it does support a notion of user-owned data. Okay, and in particular, this computer is actually able to enforce property rights. Okay, all right, so Alex, a quick interruption. So I have to confess, I got a positive COVID test this morning, and I was planning to just sort of like fight through the seminar. But now that I'm like 15 minutes in, I think it's probably a bad idea. So I think I want to just sort of leave people with the introduction. Happy to take a little Q&A, and then also happy to reschedule at some point in the future.
Whatever. Thank you very much, Tim, for letting us know. I didn't know that in advance. We could have, of course, rescheduled. Whatever you feel is best for you now in this situation.
Yeah, I mean, you know, so hopefully, you know, the 15 minutes we've had has been somewhat interesting. I think maybe let me just take questions, you know, on the first 15 minutes, and then if we could wrap it up, that would be great.
Sure, absolutely. Thank you very much. So please, for any questions, it's either you raise your hand or you use the chat box in order to ask questions, please. Thank you. So let me break the ice by asking a question. So, Tim, when you're saying it enforces property rights, we have, you know, in various legal systems or in political science, we have a particular notion of enforcement. How would enforcement work here? This question might sound stupid from your point of view, but if you're, for instance, a political scientist, or a legal scholar, you'd ask about authority and you'd ask about what enforcement mechanism do you have here?
Yeah, that's a great question. So first, like, what do I mean sort of by property rights? I mean, your property can't be seized. For example, you have the right to transfer ownership, like the right to sell, for example. And so this computer in the sky would track ownership. And so this was really kind of what Nakamoto figured out in the Bitcoin protocol, this seeming paradox between having kind of a logical computer with no owner that nonetheless was capable of enforcing kind of ownership for digital data that lives on the computer. Now, Nakamoto was specifically interested in Bitcoins. He was interested in sort of digital money, tracking ownership of that. But really, the sort of fundamentally, the solution is just about any type of digital data. So, you know, NFTs being sort of an obvious, you know, in some sense, a generic example of sort of owned digital data. So that's the first comment. You know, what should you think about when I say property rights? I mean, in the same sense that like possessions you have at your house, you think of as sort of basically yours, right? You know, you can sort of sell them, you can use them, right? You don't, you know, et cetera. Nobody can seize them without legal repercussions. And so that's the same thing that I mean here. Now, as far as the enforcement question, I mean, basically it's enforced with math. So with cryptography, right? So for example, ownership really means that you have knowledge of some private key that lets you sign transactions, right? To demonstrate your ownership. And so if you wanted to transfer ownership, you know, like transfer a Bitcoin from one person to another, you would sign that transaction using your private key. And this computer in the sky would recognize that as a legitimate transaction because the computer in the sky would verify the signature that you generated. So the computer is keeping track of the public key that's sort of associated with a piece of digital data on the computer. And then if you want to sort of, you know, and then the signature basically is your way of proving that you own the corresponding private key. And in that sense, you're the owner of it and you should be able to do whatever you want with it. So it's cryptographic is how it's enforced.
Yeah, thank you. So I have here a question from coming from David also, who asks, how and when do you think layer 2 protocols will start being widely adopted? Do you think that it will be the door where we will have friendly user interface and therefore people will most likely use the technology? What is your view?
Yeah, so that's a great question. And actually, it's sort of unfortunate. I even, like the last part of the talk is actually exactly about layer 2 stuff. So I was going to talk about SNARKS a little bit at the very end, because SNARKS are kind of originally just were invented essentially by mathematicians to just study the nature of proofs. But it turns out to be sort of a crucial technology in sort of scaling up blockchains. Yeah, so to answer your question, David, I mean, I think it's a good question. I think there's two things that need to happen. Yeah, I apologize. I think I should probably wrap up. And just
all right. Okay. Thank you, Tim. Thank you for making this effort. Probably we should reschedule at a time which is better for you. And saying this, I wish you a speedy recovery and a very mild form.
Thank you.
Thank you. Thank you, everybody, for being here. We will reschedule this talk at a better time. Thank you. Tim, I hope you get well very soon.
Thanks very much. Let me go get some rest.
Thank you. Thank you. Thank you, everybody. Thank you for being here. Thank you, Tim.
Bye-bye.
Goodbye. Goodbye now.